Hello guys, welcome everyone. This is Cybrec's Understanding Virtual Private Networks, VPN, and we will start this series with VPN technology. Okay, what I want to discuss in this course, in this video, is going to be the overview of virtual private networks. So I want to make sure that you guys understand what VPN is and when to use it. And then we will take a look at some of the specifics of VPNs. So we will, in this case, talk a little bit about tunneling to kind of like give you a better understanding of how VPNs work. And then we will also take a brief look at the VPN types and the differences between the main VPN implementations. Okay, so in this case, we will start with an overview of the technology. You can think of virtual private networks, VPNs, as of a tool that is generally meant to provide connectivity. So this is something that you will use in situations when you want to communicate entity A with entity B that you cannot normally communicate. Like for instance, a good example is when you think about your organization and someone else's organization, or maybe just one of your other sites that you want to interconnect. So let's say that you're a company A. You've got a partner that is company B, and you want to exchange some data with the partner. You're both connected to the internet, but you don't have any type of private connection, dedicated line. So a good solution for that type of design would be to use a VPN, build a VPN between A and B to establish the connectivity. Okay, so the idea is that we've got a network in the middle. As I said, it could be our network, but it doesn't have to be. Then we've got some devices, could be individual endpoints, could be subnets, networks on one side. This is going to be our A portion. Then we've got some other devices, other systems, the B portion. We can freely communicate our systems within A. We can communicate the B endpoints, the B systems together within the B organization. But the problem is that when we want to talk from A to B or B to A, it doesn't work because what we have in the middle is a public network. It doesn't have to be public network, but in most cases it will be public network that kind of like breaks connectivity. Breaks connectivity, doesn't allow to connect in the first place, I should say. So a solution is going to be to build a tunnel. This is not going to be a physical connection. This is going to be a virtual connection. Thus, virtual private network. A tunnel that is going to connect our company A with company B, and is going to allow for a data exchange. Now, an important thing here, most people, when they think about VPNs, they also automatically assume there is going to be some sort of security services ensured in place, which is not the case. It doesn't have to be. In most cases, it will, but it's not something that is kind of like inherent to the technology itself. So VPN as a technology, as a broad technology itself, it doesn't automatically provide any security services. But in most cases, what you will actually do is that the implementation of a VPN that you will select, the actual VPN protocol or just the protocol suite, is going to do that for you. So it is going to possibly apply encryption, it is going to do authentication, it is going to verify integrity of the packets, just to make sure that you're not only able to communicate A with B, but that you're also able to make it in a secure way. So it's optional, but in most cases we will actually use that. We will follow a solution that provides those different security services. Okay, but the idea is that when we are finally able to exchange the packets, this is going to, of course, happen in both directions, so we can send data from A to B, but also expect some data to be sent by B to S. It's bidirectional, and this way we can eventually exchange the information with another entity or with basically maybe another part of our network that is not geographically in the same place as we are. So that's the idea behind virtual private network technology. This is why it was designed, invented in the first place, to provide connectivity. That's the main function. Okay, as I mentioned, in most cases, it is going to be an unsecure network that sits in the middle, but it doesn't have to be. It doesn't have to be the internet. In some situations, it is even possible to use VPNs within a single organization, within a single entity, for different reasons, some of which we will take a look at in one of our next videos. But an example can be just to build a tunnel that is going to be used for as a temporary solution, or maybe for traffic engineering purposes. So we've got different use cases here. We will look at this stuff later. And then, as I said, remember, the VPN doesn't automatically imply security. Whether the tunnel, the connection is secure or not is going to depend on the implementation. Now, before we talk about we'll actually look at some of the examples of secure and insecure VPN communications. Now, let's also talk about the specific feature that allows a VPN to function, that is known as tunneling. Okay, because tunneling is what actually allows a VPN, tunnel to function, what allows VPN technology to work. Tunneling is what builds this connectivity on the back end. So when we build a VPN tunnel, in the background, a technology that allows for the tunnel to function is going to be tunneling. And tunneling is basically an additional so-called encapsulation, how it is done at the packet layer. So for those of you who are familiar with networking basics, we know that in order to transmit data from one point to another, what happens internally, like at the network layer, is that we will take the data, we will wrap it around a special structure called header, which header is going to eventually allow this packet. There are going to be multiple headers, typically, depending on the layer in which we operate. But the header itself it can be described as an envelope for our letter, where letter is going to be our data, and the envelope is going to tell the postman what is the source, who sends the letter, and more importantly, who we want to have this letter to be received. So where we want to send the letter to. So this is what headers, or basically encapsulation, makes for in networking. It's what allows those devices, this whole infrastructure in the middle between the source and destination, to figure out where to send our data. And also on the way back, when someone replies back to us, wants to talk to us on the way back, this envelope, this header, is also what allows that to function. Okay, so here the idea is the same. The tunneling is basically an additional level of encapsulation. And specifically in case of tunneling, there are going to be three different protocols involved in the process. Okay, so we've got the carrier. The carrier is what we use strictly for transportation. Okay, so the carrier is what allows our packet, our data, to be moved by the infrastructure in the middle between our VPN gateways or VPN endpoints between the VPN devices, the devices that build the actual tunnel. Now, encapsulating protocol is this is what makes the tunnel itself. This is what allows for tunneling. And finally, the passenger protocol is basically our data. So it's kind of like we take our data, which is going to be the passenger, we wrap it around the encapsulating protocol. This is what's eventually going to build a tunnel, and then the carrier protocol is responsible for the movement of the data across the network in the middle, across the infrastructure over which we create our tunnel. Okay, another thing I want to discuss in this course, in this particular module, is gonna be the two main VPN types. So it's good to know the difference between these, because it's pretty much anytime you create a VPN, you will be either referring to a site-to-site or a remote access VPN. Okay, so let's start with site-to-site. Site-to-site, one of the two major VPN types, also known as LAN to LAN or L to L. This type of a VPN is what is generally used to interconnect groups of devices, groups of systems. So here, the idea is that we will want to communicate more devices, more than just one, on both sides of the tunnel. We will have a subnet, maybe network, maybe subnets or networks on one side. We will have some subnets, networks on the other side, and we want these two to be able to exchange information. This is what is known as a site-to-site VPN, because in this case, the devices that build the actual tunnel are not the tunnel endpoints themselves. They themselves don't participate in data processing. So they only act as the proxies, as man in the middles that take data from one side, pack it to the tunnel that they built, that they established in the first place, send to the other VPN, to the other end of the tunnel, so to the other VPN gateway, which kind of like decapsulates the data, unwraps them, and sends to the destination on its side. So in this case, we are dealing with a group of devices. This is site-to-site. And this solution is what you will commonly see used to extend your the reach of your organization, or basically to interconnect the different portions of your organization to kind of like build a private wide area network. A wide area network that is going to work on top of the internet, on top of the public backbone. Now, what is going to be the difference? How is remote access VPN gonna be different from site-to-site? Okay, so as you probably guessed, in this case, there is going to be less devices, less endpoints involved in the tunnel creation. Specifically, with remote access, in a typical scenario, there is going to be just one device that wants to connect to the network on the other side of the organization, or basically wants to connect to the organization to some portion of it across also typically a public backbone, the internet, just one device which is going to act as our endpoint. So in this case, we can actually talk about the client and server architecture, because the endpoint is going to act as a client, and the device that terminates the tunnel, VPN gateway, in this case, is going to act as a VPN server. So it gives connectivity service to the connecting client, so it can get to the network that is located behind our gateway. And this is something that you will see is commonly used for remote working, like when you want to work from home, or maybe from from some sort of off-site location like a hotel, maybe bookstore, or basically another good example is something that we use every day, which is basically a secure web access. So this is anytime that you connect to a website with HTTPS in front of the URL. Because HTTPS is basically SSL, TLS in the background, which is a special protocol that secures communication between the browser, typically a browser, and the destination server. So this is also an example of a VPN, of a virtual private network, when you connect to a website via HTTPS. Okay, remote access in those cases, notice that we will also typically need to have an additional client software. It could be something as simple as a browser, which is not actually considered as an additional software in many cases. But for more sophisticated applications, like when you want to work from home, you want to get access, full network access, you will have to install additional software on the client PC. Okay, before we finish, let's also talk about the types of VPN implementations, insecure versus secure. So in case of insecure implementations, in this case, we are talking about solutions, VPN protocols that do not provide any type of security services. So basically, those that exchange data in clear, where a good example of such technologies is going to be GRE, generic routing encapsulation, and layer 2 tunneling protocol, L2TP, both of which are clear text solutions. The GRE is for multi-protocol tunneling. L2TP, this is an example of layer 2, a VPN implementation. But the key thing is that both of these protocols, they exchange data in clear without any security services involved. And as opposed to secure implementations, where the data exchanged is going to be protected, the two most common industry standards we will see, this is going to be IP security, or basically IPsec, and transport layer security I just mentioned when showing you remote access. Examples, TLS, or basically previously known as a secure socket layer, SSL. So these two, IP security and TLS, we will look at these two in just a little bit more detail in our next session. Just remember that not every VPN is secure just because of its VPN. Whether it is secure or not depends on the VPN implementation.